Okay, we have here another integral from the MIT Integration Read 2025, number 15. We've got the integral from 0 to 1, square root x times 1 minus x dx. Okay, I did this problem recently using beta function, and we got a suggestion in the comments from David Kravitz doing it a different way. I'm not sure if I've got the exact same method, but I think this is the same idea. So to get started with it, what I'm going to do is, let's just multiply in the x. So what we're going to have here is it's going to become x minus x squared. And then I'll complete the square on it. First, what I'll do, let's just factor a minus out. I kind of like to have it this way. So we'll have it as x squared minus x. And that's actually 0. So let me get rid of that. That's really x squared minus x right there. And then completing the square on it, what's going to happen, take 1/2 of the coefficient here. We have x minus 1/2 squared. Multiplying that out, you're going to get x squared minus x plus 1/4. I'll subtract off 1/4, so I'm not changing it. And then when I multiply back in the minus sign and reverse everything, we have 1/4 minus x minus 1/2 all squared. We'll take this and throw it back into the square root. Then from here, you could do this with a trig substitution on this part right here, but instead what I want to do, let's just set this whole thing equal to y and create an equation. So we'll have something like y equals square root of 1/4 minus all this stuff here. Then I'll rearrange it. Let's square both sides. So we'll have y squared equals this stuff. And then adding this on both sides, we'll get this on the left side. So what we're gonna have here is gonna be y squared plus x minus 1/2 all squared. 1/4, I can write this as 1/2 squared. But now writing it this way, what we have here, this is in the form of the equation for a circle with the center not at 0. So our formula for this is going to be, we can write this as y minus b squared plus x minus a squared equals radius squared. So for this circle, it's going to be centered at point AB, and it's going to have the radius r. So looking at what we have here, our radius is going to be this value right here. So we have radius 1/2. On the y value, the b value is just going to be 0 because we just have y squared, but this a value here is also going to be 1/2. So if I do a really rough graph of this, what's going to happen? We're centered at 1/2. So let's say 1/2 is over here somewhere, and our radius is 1/2. So our circle, to the left, it's going to go 1/2 is going to bring us to 0. To the right, 1/2 is going to bring us to 1. So the circle is going to look something like this, if I can draw it okay. So for the integral, what we want is the area under the curve from 0 to 1, but that's fine because our whole circle is within the area, so that's going to be pretty simple. One thing that we have to consider is, keep in mind, the square root's always positive, so really coming over here, this value is always going to be greater than 0 or greater than or equal to 0. So if our y value is always positive, we're only going to want this area up here and not any of the negative values. So for the area of the circle, that's going to be really easy to calculate because area is just pi r squared. The only thing is we only want half of a circle, so what we want for this is going to be pi r squared over 2. And we know our radius is 1/2, so we can just plug in and get a solution. So we're going to have pi 1/2 squared over 2. That's going to be 1/4 divided by 2. For the solution of this, we just get pi over 8, and that's it. And of course, if you want to do it a faster way, you could look at the graph. You can see the area is going to be 1/2, and then you can go right to this point. You don't really have to calculate all this, but I kind of like to show out all the steps. Okay, there you go. Nice alternative method on this one. Thanks everyone for watching. Have a good day.